A very warm welcome, everybody, to the Mechanical Engineering Open Day of 2021. It's really great to have you all here. It looks that we have a whole host of attendees, and it's wonderful to have you all in the room. My name is Brandon Collier-Reed, and I'm the head of Department of Mechanical Engineering. And over the next half an hour, we're going to have a journey through what mechanical engineering is, what our department can offer you, and we'll also have an opportunity for you to ask some questions and hopefully be able to answer all those burning issues that you might have about what it means to be in our department. There's an agenda of what we're going to talk about. I'll have a brief welcome by myself, and I'll tell you a little bit about the department, as I've said. We've got a member of our student body, our head class representative, who will then say a few words to you. And then we'll have a few minutes to be able to go through some questions that you might have. I want to invite you to ask your questions at any time in the chat. We have a team on hand who will be able to respond to those immediately. Some of them we'll hold towards the end to be able to give me the opportunity to present those back to you. But please don't hesitate from putting your questions in the chat right from the start. Also, we'd be very interested to hear whereabouts in the country you are, or in fact, even overseas where you are. So if you have a moment and you're able to access your chat, just type the city or town that you're from, or where in the world you're from, just so we get a sense of who we're talking to and where you're all from, because I can also see the chat, and it'll be really nice to know who our audience is. All right, let's get stuck in. As I said a few moments ago, my name is Brandon Collier-Reed, and I'm the head of Department of Mechanical Engineering. And the Department of Mechanical Engineering is just over 100 years old now, and we're very proud of our history. We're very proud of the graduates that we produce. They really go on to make a name for themselves in industry and have made a real contribution to society. And if I have a few moments later, I'll tell you a little bit more about who those people are that have really made a name for themselves. I'm going to take a few moments now just to talk about mechanical engineering in general, talk about the programs that we offer, and give you a little bit about where our graduates can work when they do move into industry. But this all starts with a team. And what I've got on the slide at the moment is an image of some of the staff in our department. It's you, the students, who are the people who we're working to educate, to give you the best education possible. And of course, we've got this wonderful campus in Cape Town, the University of Cape Town. So what you're seeing at the screen at the moment is the team, the cluster of people that really work together to do what it is that we do so well, I believe. And just a little bit about our department. The QS rankings for 2021 have just been published. Of course, we can all take rankings with a little bit of salt, but when they work in our favor, it's also very nice to be able to publicize them. So UCT is the best engineering. UCT offers the best engineering programs in South Africa at the moment. So that's a really big feather in our caps. What's also very useful is that the mechanical engineering department at UCT is considered the best in Africa. And we're also very proud of that. And that's because of the people that you see on the screen at the moment. It's the team, it's the students, it's the staff, it's who we are as UCT, all working together to give you that excellent education, to be able to provide robust research opportunities that really give us the opportunity to shine in the international marketplace. I do also want to just highlight that the other institutions in South Africa are also excellent. Particularly in the engineering degrees that they offer, because we are accredited by the Engineering Council of South Africa. So the Engineering Council of South Africa, or EXA as they're called, every 5 years goes to the engineering programs across the country, and they accredit them to make sure that they are up to the high standards that they demand for the professional engineers of the future. And so we have our most recent accreditation was passed with flying colors. Our next accreditation is taking place later this year. But really what that gives you is a level of confidence in the quality of the education that we provide. But I also just want to highlight that the other institutions also provide quality education. We just believe ours is better. Okay. So the one thing I just want to highlight at the moment as well also is that the Department of Mechanical Engineering, if you are a student with us, we offer a very broad education. Okay, it's if you think of, say, chemical engineering, you can quite carefully picture what chemical engineers do, or you can picture what electrical engineers do, you can picture what civil engineers do. And if you've been to those talks earlier today, you would have heard the sorts of things that they dabble in. The Department of Mechanical Engineering, the education you get is a broad education. It really allows you to make a difference in the world, to be able to contribute to the community in a way that's really, really meaningful, because we give you skills that are sort of located and based in this ability to design the solution to problems. And we're very proud of that, and we're very proud of the skills that we'll develop within you to be able to make that meaningful difference in the world around you. And what I like to do often is to use an analogy of a general practitioner versus a surgeon. You don't study to be a surgeon, for example. You don't study to be an ophthalmologist. You study to be a general practitioner, and then you go somewhere in the world and you study further and you become the specialist surgeon, for example, or anaesthetist. Same with if you're wanting to do aeronautical engineering, or if you're wanting to go and do automotive engineering or something like biomedical. Do a solid undergraduate qualification in engineering, and we think mechanical and mechatronics engineering are the best based for that. And then as a postgraduate qualification, you can go and study one of the others. But I'm sure that will come up in the Q&A in a few moments' time. I'm very conscious of the time, and we do have our class representative, Purusha, who will be talking to you in a few moments' time. But what I want to do is just highlight a few other little bits and pieces from our department, starting particularly with the two programs which we offer. In our department, and you can see on the slide, and this is small like that, so what I'm going to do is just expand it like so to give you a little bit more opportunity to see what it says. Don't worry too much about the text, because I know it is small. This is available on our website, and a more detailed description of what I'm going to talk about now is there as well. But in our Department of Mechanical Engineering, we offer 2 degrees, 2 programs, one in mechanical engineering and one in mechanical and mechatronic engineering. Now, the reason why I'm talking about this specifically now is because I'm wanting you to understand that in the Department of Electrical Engineering, they offer a degree called Mechatronics. And in the Department of Mechanical Engineering, we offer a degree called Mechanical and Mechatronic Engineering. So the word mechatronic appears in 2 programs or 2 degrees in our faculty. So when you decide which one you're wanting to do, just bear in mind that you need to decide which one of those is important to you. And I'm going to use a very, very simple example to try and illustrate this. It's not the best example, but hopefully it will resonate with you a little bit. And in the build up to that, if you look at the 2 columns on the right-hand side of the screen, the one in mechanical engineering, and you look at in the middle, it's talking about, and I'm going to focus in specifically on the mechanics and electrical and computers. So I was talking about the difference between mechanical and mechatronics, which is primarily, it's related to the balance between the amount of mechanics that's in the program balanced against electrical and computers. So in the Department of Mechanical Engineering, our focus is very much on design and mechanics and mechanical engineering. And so if you do mechanical mechatronics, the amount of mechanics in your program is 50%. So it's half your program is focused on mechanics. Then your electrical and computers is 25% of your overall degree. It's just the other way around in the mechatronics program in electrical engineering, where the amount of electrical computers is up to 65% and mechanics is at 10%. So you can see the mechanics in the mechatronics program is a very small percentage of the program, and they focus quite directly on electronics and computing. To try and make that, to drive that point home, what I want to do is just use the example of a robot, because of course robots and mechatronics are sort of, they all together as one. In our department, in the mechanical and mechatronic degree, what you will do is you will be focused on the robot itself. So the actual structure, the structure is not going to fall over. Okay, you're going to design a robot which is structurally sound and can move and do what it needs to do. And you will be able to go and design and develop the electronics to enable that robot to move around and do what it needs to do, and the control associated with that. In the mechatronics program in electrical engineering, your focus is going to be quite a lot more on ensuring that the control, the electronics, and everything associated with that robot is very well structured and very well done. Your focus is not so much on the actual structure of the robot itself. Of course, often you'll be working in a team, and so the strengths of everybody will be working together. And so as an engineer, as part of the team, you will be able to develop a very robust and sound robot. I do just want to encourage you, if you are thinking of mechatronics in either one of the programs, just go along to the respective websites of ours so that you can just read a little bit more in depth about what it is that we offer. Because I've lost my picture feed now, it's a little bit more tricky for me to introduce Purusha with a slide. So Purusha is our Purusha Raidu is our head class representative, and she plays a very important role in linking what's happening in the student body with what's happening with us as academics and support staff in the department, and to ensure that we actually continue the high quality education which we set out to provide. So what I'm going to ask now is I'm going to ask the producer back at the mixing session just to bring Purusha on live so that she can spend a couple of moments just sort of outlining a little bit about herself and her thoughts about the program. So Purusha, over to you.
Hi everyone. So yeah, as Brandon said, I was just asked to share a little bit about my student experience and give you some insight to the degree. So I want to start with painting a picture of what a typical day as a student in the Mech Eng department is like. So picture this. You wake up in the morning and you flop out of bed and over to your laptop to start your lectures. They could be thermodynamics, manufacturing science, or mechatronic systems. Skip a couple hours ahead and you're heading up to campus for your homeroom session. You walk into Menzies, one of our Mech Eng buildings, and you're greeted by an excited buzz and friendly faces, lecturers included. You're now in your homeroom session and your professor, probably Brandon, is going to whip out a whole bunch of two-stroke engines. Your task is to take one apart and reassemble it. Another couple hours ahead, you're sitting and working on, say, a vector calculus assignment. And after struggling through derivations, you finally get the answer. And the feeling you have is literally like the bass just dropped. So why I went into engineering is because of the impact it can have on the world around us. Whether it's confronting climate change or advancing renewable energy or designing a car, mechanical engineers' contribution to the world can really improve our way of life. So I grew up in a small town in Natal, and when I went into Mech Eng, I really wanted to join the automobile industry. But 4 years at UCT has really shown me how broad the mechanical engineering industry can be. So now I'm going to be graduating this year and next year joining the telecommunications field where I'll be developing 5G tech in Africa. Not only will I be able to contribute to the technological development in Africa, but I'm super excited to have the opportunity to help others and pursue my passion of philanthropy. So engineering really has the potential to not only achieve societal growth, but I think the personal growth that you can experience while doing this degree is really, really phenomenal. The mechanical engineering department at UCT has given me a renewed perspective of the world around me and introduced me to people, and the opportunities here really just are great. So yeah, not praising the department, but kind of. I won't say engineering isn't difficult, but it really is a fulfilling and promising career opportunity. And it opens up broad horizons for the emerging professionals. So I really hope that you are at least somewhat inspired to look into Mech Eng a bit further, and maybe we'll even see you around Menzies next year. Going back to Brandon, because I think we're going to do some questions now.
Great, thank you very much, Purusha. You can see the students that we have in mechanical engineering are amazing, and I just want to just personally thank Purusha for the role that she's played over a number of years now in our department, just ensuring that the voices of the students are actually heard, and we take that very, very seriously in our department. What we've got, I've looked at the chat, and I'm amazed at the different places across the country that people are joining us from. So it's really great to have you all here, and I'm really hoping that you recognize the passion that we feel about our department, the passion that we believe that our students bring to the department, and how together as a team we can work to ensure that you sort of harness your full potential and become these change agents for society that I know you all want to be when you graduate and you go out into industry and you make a name for yourselves. We have time now for some questions and answers. We put 15 minutes aside for this because it's often in the questions and answers that we're able to really sort of dig into the particular question that you might have. We've got our departmental manager, Carmelita Yonko, who has been looking very carefully at your questions and is now in an opportunity to be able to to ask some of those on your behalf, and then we have another team, myself as one of them, who will be able to answer them as far as possible. I just want you to understand that we won't be able to get to all of your questions just because of the time available here. But what we are going to do is we're going to take all of your questions and we will answer them all in a sort of a FAQ, a frequently asked questions format, and we'll make those available on our website so that your question will be answered even if you don't have the time just at the moment to be able to do so. So with that said, I hand over to Carmelita to raise some of the questions that you've been asking in the chat forum.
Good morning, everyone. The first question comes from Brendan. He asked, how can mechanical engineers contribute to the making of renewable energy sources?
Oh, that's a really good question. It comes back to the point I was making earlier about mechanical engineering, our department, which of course, remember, has those 2 degrees in it. And I'll just talk about the department as a whole. What's really nice is if you're focusing in on sort of what it means to I got distracted because suddenly it looks like I'm not sure whether my feed has disappeared or not, but hopefully you can still hear me. To be working in the renewable energy space, remember, and I'm just going to use a mechanical example. Remember the structures of the renewable energies, whether it's a windmill structure, a turbine, or whether it's a PV cell on a roof or something like that. Remember, all of those are structures. So you need to design the ability to be able to keep those structures in one place, to be able to integrate the electronics and the systems and maybe using generating hydroelectricity. All those structures, all the things associated with that are critical component of the people from our department able to sort of get those out and set up in the industrial space. So there's absolutely no doubt that the graduates from our department can work in the renewable energy space. Typically, as I said before, you'll work as part of a team because there are a number of people who will be in that team that will all contribute towards the broader goals of that particular project. So Carmelita, another question.
Next question is, do we offer auto mechanic type of engineering?
Yes. So what we don't offer specific things like automotive engineering or aeronautical engineering or biomedical engineering, but that's the point I was trying to make a little bit earlier, is that our belief is in fact that if you're wanting to do one of those more specialized engineering degrees, what you should do is you should do that as a postgraduate qualification. For your undergraduate qualification, you should get a really solid undergraduate education in either mechanical and mechatronic engineering. That'll set you up with the foundation to be able to do that at a specialist level a little bit later on, typically as a master's qualification or even maybe as a PhD if you want to go into the research space. Carmelita, another question.
Well, a follow-on to that question is then how do you move from mechanical engineering into automotive engineering?
Great question. So my recommendation would be that you do mechanical engineering. If you're going into automotive engineering, you'll do mechanical engineering as your first degree. And then you look around in the world. Where is the best place in the world that you can go and do a master's qualification in automotive engineering? And it might be in South Africa, it might be overseas, it might be at a university that's located right next to BMW or right next in Stuttgart, somewhere in the world where you can really, really get the best education to be that automotive engineer and make yourself truly employable. Hopefully you'll come and work back in South Africa. Maybe you'll go and spend some time in Port Elizabeth. Maybe you'll study in Port Elizabeth and you will do your postgraduate qualification in automotive engineering. Thanks. And another question, Carmelita.
Maybe 2 questions. So can you elaborate more on in-service training and placement? And then is there a number in the limit of first-year students that you take in for Mech-Eng?
Great. So the degree that we offer, a Bachelor of Science in Mechanical Engineering or Bachelor of Science in Mechanical and Mechatronic Engineering, they don't have a component of in-service training like you would have if you were at a University of Technology following a diploma or the Eng Tech, for example. Particularly in the diploma, there's a greater emphasis there on in-service training. We have a requirement for what we call vacation training, which is a short 1 to 2 month period twice in your degree, where you'll go out into industry and get some experience what it means to work in an industrial environment. But we don't specifically have in-service training in the classic. We don't have a requirement for in-service training in the classic sense, as you might be imagining it, at University of Cape Town. As far as our intake into our department, our target is 130 odd students, 132 actually. This year we unfortunately, no, not unfortunately, that's a wrong way to say it. This year we were very, very, very popular, and we had a large intake, and in fact we were 175 odd students, and we're loving all of them. It's great to have all of the students on the program. Of course, it's just, I just want to remind everybody that to get into engineering in one of the universities like University of Cape Town, it's really important that your maths and your physical science marks are really good. And we're talking sort of in the 70s into the 80s onwards, because the mathematics and physical science play a fundamental role in allowing you to put the building blocks in place to be able to become an engineer in due course. Because we develop in you the competence to be able to solve complex engineering problems. And the ability to deal with that complexity means that what you've done is you've got a solid foundation in maths and physics, which means you need that at school as well to allow you to be able to thrive and succeed in maths and physics when you come to university. Carmelita, another question.
Does the mechanical engineering course or the mechanical mechatronic course lead to a career in aerospace engineering? And I think, Brandon, maybe you need to elaborate more on our PG as well, because aerospace is coming up quite a lot in the questions, and we only have so little time.
Yeah, that's a good idea. So when we do this in person, I'm always amazed at. I always ask the question: who's interested in mechatronics, in aeronautical? Who's interested in biomed, etc. And almost always people put their hand up. I mean, a large number of people put their hand up when you're illustrating, talking about aeronautical engineering. It's a huge draw card. And in our department, we are very lucky to have one of the top researchers in aeronautical engineering in the country, Arno Milan. He's got a South African research chair in aeronautical engineering, and he is doing a significant amount of work with Airbus. And many of you will know that when an Airbus or a Boeing, whatever it is, flies, the fuel is in the wing. So just imagine that for a moment. The fuel is in the wing. And now, if the wing is not completely full of fuel and the aircraft is moving from side to side, you can imagine the fuel is sloshing from side to side. And you can imagine as it gets to the one side, it pushes the aircraft to the one side. As it flows to the other side, it hits the wing on the other wall and it pushes the aircraft to the other side. There's a lot of research that he's doing at the moment into the slosh effects of fuel inside the wing of an Airbus. And of course, other really quite sophisticated research into the aerodynamics associated with aircraft. So in our department, doing mechanical engineering, you will do fluid dynamics courses, and those fluid dynamics courses give you the fundamental ability to be able to develop those higher order research type skills and industrial type skills that you need to understand how to work with aerodynamics and aeronautics. But what we don't do is offer specific aeronautic courses. Okay, our courses are more generalized and focus on aerodynamics and gas dynamics and fluid flow and things like that, which of course all applies to aeronautical engineering. But then what we do is you'll either do research in that in your master's degree with Arno, or you'll go, as I've said, you go somewhere else in the world or to another institution, and you will do aeronautical engineering as a postgraduate degree. We have 5 minutes left and lots of questions. So Carmelita, fire away.
Too many questions, but one of the questions that I think is important is for them to understand, or one of the questions that was asked is, what are some of the postgraduate options after a bachelor's in mechanical engineering?
Great. So we got in our department, we've got some very internationally recognized research areas or research groups. For example, we've got the one I've just referred to now, which is the Aeronautic Engineering, which is computational fluid dynamics is what they focus on. We've got a research group which is focused very specifically on blast impact survivability. Okay, so that's BISRU, blast impact survivability, and they deal with very much about structures which are affected by blast loads. So it's one of the few research laboratories in the world actually that have the license to be able to use plastic explosive to be able to do that impact on structures to see what happens. Like, for example, if you're driving in your motor car and the motor car crashes into a wall and you're wanting to simulate that, you can do all the analysis of it, but you still want to do a practical experiment to see what happens. So how do you simulate that very sudden impact? And so you put some explosive on the front of a tube and you blow it up and see what happens. So that's another research area. We've got a number of research areas in our department, including the Center for Materials Engineering, where the material structure of the components which we use to design and build things, you need to understand that. If you're wanting your design to, again, we are talking about the impact of a vehicle. If you're wanting now to design the crumple zone of a motor car to crumple in the way you want it to do, you really need to understand what's happening to the material in that moment. And so the people in the materials engineering research area, they understand that explicitly. They also do work, for example, in aircraft structures. If you're building a wing of an aircraft, you want to know the forces associated on the wing, what's going to happen. And so that we've got the aircraft. We've got an engineering education group as well, who have a very strong focus on ensuring that the quality of education is moved forward and how education takes place moves forward, amongst a number of other research areas. But given the time, what I'd rather you do is you just go to our mechanical engineering website, and we've got all our research areas are listed there with links through to the pages which describe them, as well as the people who do it. So if you have any questions about it, of course, please just drop them an email and they'll be very happy to chat with you about that. We've got 2 minutes left, Carmelita. What are some more questions that we can squeeze in?
Is there a course you can take to improve your maths or physics outside of high school that you can use to apply?
Okay, that's a very, very important question, because yes, our maths threshold is 80%, which is quite challenging, I know. So the University of Cape Town doesn't offer specific courses outside of the curriculum, which allows a student to sort of get on top of their mathematics, particularly if they're wanting to use that, if you're wanting to use that as a way to be able to enter into the program. So that typically what happens is that you will either if you aren't happy with your mathematics results at the end of your matric year, you can do that mathematics again, of course, and do that subject again and have a better mark. Or you can, of course, go and then you can register for mathematics at the University of South Africa at UNISA, and you can do first year mathematics through them. And then, of course, you've demonstrated that you are comfortable with first year mathematics. If you pass well, you can use that as a way of helping to support your application. So we've got a few seconds left. So just what I wanted to do is just take the opportunity to really thank you for spending time with me today. It's been wonderful having you here. If you have any questions, please just come to our website, check out what we offer, communicate with us, ask us the questions, and we'll be happy to answer them for you. Once again, thanks for being here today, and thanks to the team for making this possible.